All right, today we're taking a look at our study guide for Unit 10 here on solving quadratic equations. We're going to be having a quiz on Wednesday, okay, so we'll be doing some more review tomorrow. But I wanted to walk you through all the stuff we had talked about in terms of how to solve quadratic equations. So, first question, we're going to solve these algebraically. Now remember, the three methods we talked about using algebraically were factoring, the square root, so taking the square root of both sides, and then the third one was the quadratic formula. Well, four, because you're completing the square. Those would be the algebraic methods. So first thing I want to do is take a look, all right, at what we're given, the question we're given. So we're going to recognize it's a quadratic equation because it has a highest exponent of 2. It's got that x squared in it. So if it's if there's all three terms, the ax squared term, okay, the bx term, so the term with an x, and the c term, okay, we're going to want to get it equal to 0 and then see if we can factor. Okay, remember the factors we're looking for are GCF, okay, the difference of two perfect squares, and then if it's 3, this is going to be 2 terms, okay, and then if it's 3 terms, we're going to check out the trinomial method, which is when we did our x, okay. So that's essentially what we're looking for as we work along here. Now, if there's no linear term, so the term in the middle is missing, okay, what we want to kind of do, one way to do it is just to take the square root of both sides. So get the x squared term by itself, take the square root of both sides. So for example, first question, we can divide both sides by 10 to get the x squared by itself. There's no x term, right? The linear term is missing. So we get x squared equals 81. And then we're going to take the square root of both sides. Now remember, when we take the square root of both sides, we have to remember to include the plus minus. So plus or minus 81, so x squared equals, and then what you might want to do is, when you know you're going to take the square root of both sides, give yourself a little bit of room after the equal sign. So square root and square root, include the plus or minus here, right after the radical, and then we end up with our answer. So x is equal to plus or minus, and the square root of 81 is just 9. So this is simplest radical form. This is simplest radical form. So essentially our two answers are, and if we want to do it in set notation, we would do 9 comma negative 9, okay? Or we could say x equals 9 or negative 9, or just x equals plus or minus 9 is fine. Now, second one, we already have the x squared term by itself, so we'll go ahead and take the square root of both sides. So the square root of x squared is equal to plus or minus the square root of 19, and this is in simplest radical form. Now, had this been the square root of 18, I would want to separate the radical into a perfect square times another number. So 1, 4, 9, 16, 25, any of these are multiples to give you 18. We would say 9 times 2 is 18, and the square root of 9, because 9 is a perfect square, is 3. This would be 3 radical 2. So if it was the square root of 18, the simplest radical form would be 3 radical 2. The square root of 19 is prime. 19 is a prime number. Only 1 in itself go into 19, so we just get left with plus or minus the square root of 19. So just a review of simplifying radicals, but if it's already in simplest form, there's no perfect square factors, then we just leave it as is. Okay, going down to number 3. So once again, this does have this linear term, so we're going to look to factor. We're always going to check for the GCF first. We can see there is a common term of x. So if I take the x out of here, I'm going to get x times x minus 81 is equal to 0. And then I can't factor the inside because it's not a perfect square, x squared. X is not a perfect square, so we have to stop. Then I'm going to set each factor equal to 0. So either x is equal to 0 or x minus 81 is equal to 0. This is one solution. We're already done. The other one is to add the 81 to both sides and get x is equal to 81. So the solution set of this would be the set of 0, 81. Or I would just say x equals 0 or 81. This is another way that you can write this. Okay, third one. All right, or sorry, the fourth one here. X squared minus 8x equals 48. So once again, it's quadratic. I have the linear term, so I can't just take the square root. So I want to get this thing equal to 0 first. So minus 48 to both sides, and then we're going to look to factor. So no GCF, because this x squared doesn't have a number, 48 doesn't have a letter. I don't have two terms. I do have three, so I'm going to look for the trinomial. So I want to multiply to give me negative 48 and add or subtract to give me negative 8. Okay, now 48 has a few factors, right? 1 and 48, 2 and 24, 3 and 16, 4 and 12. We have 6 and 8. So just be careful. Like 6 and 8 might seem to work, but I can't get negative 8 from 6 and 8. I can from 4 and 12, though. So 4 and negative 12 would work. And then I would get x plus 4 times x minus 12. Keep this equal 0. And then we go ahead and solve. So from here, we're going to set each factor equal to 0. So x plus 4 is equal to 0. In order for this to be true, x would have to equal negative 4. And we can really just show our work by subtracting 4 from both sides. Or x minus 12 is equal to 0. And x is going to equal 12 after we add 12 to both sides. Okay, so the answers, set notation, are negative 4, comma 12. It could be written on the regions like that, so that's why I want you to see it. Or I can just say x is equal to negative 4 or 12. Okay, fifth one. So the sixth one, by the way, is a repeat of this, so we're not going to do this. Just ignore that. But let's take a look at the fifth one. So first of all, I'm going to try to factor. It does have a common factor of x. And then I'm left with x squared minus 25 equals 0. Now we're going to check to see if we can factor the inside. And these are perfect squares, and we're subtracting. It's a difference, so we can factor this, take the square root of both. So x and x, 1 plus, 1 minus, and the square root of 25 is 5 and 5. Don't forget the x we took out first step have to stay along for the ride. And now I solve from here. So first factor, we set it equal to 0, and we're done. Or the second factor, we set it equal to 0. And then the third factor is x minus 5 equals 0. So x plus 5 equals 0. X would have to equal negative 5 for that to be true. We can subtract 5 from both sides to show the work. Or we can, once again, if x minus 5 equals 0, then x would have to equal positive 5. And we can show that by adding 5 to both sides. So our three solutions, set notation, are 0, 5, or negative 5. And we could do 0 comma plus or minus 5 as well. Or we can do x is equal to 0 or plus or minus 5. Kind of like that. All right, and that is factoring, solving by factoring there, or taking the square root. On the next page, we have completing the square. So remember, in this one, we want to first get our equation so that just the x's, okay, x squared, no term in front, okay, plus bx is equal to some number, c. Then we're going to add b over 2 squared to both sides, okay? And this is going to factor into x, whatever this term is, it's plus or minus, okay? B over 2 quantity squared. And then we're going to take the square root of both sides and solve. So first step, we want the x is on one side, so minus the 6 from both sides. And I get x squared plus 8x equals negative 6. Second step, we're going to do the b over 2 squared. So remember, b, if it's ax squared plus bx plus c, okay, equals 0. Let's put a weird looking plus sign. The b is 8. So 8 over 2 squared is 4 squared. This is an important number, remember that, and that's 16. So we're going to add 16 to both sides. So x squared plus 8x plus 16 is equal to 10. Now this factors into, and this is that important number we talked about, okay, x plus 4 squared. And this is equal to 10, not 0, by the way, equals 10. And then I'm going to go ahead and take the square root of both sides. Now, I'm just going to clean this up a little bit here. So I'm going to move this parentheses a little bit closer. Squared equals 10. Okay. So now I'm going to take the square root of both sides. And remember that plus minus. And then this square root and the square cancel out. So we just get x plus 4 equals plus or minus the square root of 10. And then we're going to subtract 4 and we'll have our answer. X equals negative 4 plus or minus the square root of 10. You could round that to the nearest decimal by typing in your calculator, but no need to there. Okay, second one we're going to do, same thing. So subtract the 28 from both sides. X squared plus 12x is equal to negative 28. We're going to go ahead and do that b over 2 squared next. Okay, so b, remember, is the term with the x on it, which is 12, divided by 2 squared. Oh, getting ahead of myself there. Squared. And that's 6 squared. So remember, that number is important, which is 36. So we're going to add 36 to both sides. So we get x squared plus 12x plus 36 is equal to 8. Okay? So factoring. Okay, it's x because this is positive plus, and then we're looking at our b over 2, which is 6, so 6 squared. And then we're going to go ahead and take the square root of both sides. Remember that plus or minus. Now, the square root of 8 does actually simplify, okay, into what perfect square? So this perfect square that multiplies together to give you 8 would be 4 and 2, and the square root of 4 is just 2, so this becomes 2 radical 2. So we could see this. If we drop this out, we'll get x plus 6 equals plus or minus 2 square root of 2. Okay? And I just want to show you what happens if we do simplify. So we're going to subtract 6 from both sides. So we get x is equal to negative 6 plus or minus 2 square root of 2. Now, I can't subtract these two numbers because this has a radical and this doesn't. It's kind of like if this was an x. Okay? I have to have the like radicals, the same number inside the radical in order to add these together. So this would stop right here. Okay? Most instances, I would basically check my answer by using my calculator and comparing it to the answers in the multiple choice question. So I could have also just done x equals negative 6 plus or minus the square root of 8 if I didn't simplify. Okay? It's just that the square root of 8 became 2 square root of 2. All right, coming on down to the quadratic formula. Now this is on your Regents exam formula sheet, so if you are taking the Regents exam, you'll see it. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, this is supposed to be ax squared plus bx plus c is equal to 0. So make sure it's in this format before you start. And then we're going to identify. So a is 3, b is 7, and c is negative 1. Okay. We're going to go, instead of simplest radical form, and I'll change this on your sheet that you guys have in your folder. We're going to go to the nearest, we'll say 100th. D-R-E-D-T-H. Okay. So x equals b is 7. So negative, remember we use parentheses when we plug in. Okay. Negative 7 plus or minus 7 squared minus 4 times a, which is 3, times c, which is negative 1, all over 2 times a, which is 3. Okay, let's simplify this out. So this is negative 7 plus or minus the square root of 49. Negative 1 times 4 is negative 12 times negative 1 is positive 12, all over 6. Okay, so the square root of 49 plus 12 is going to be 61. Negative 7 plus or minus the square root of 61 over 6. And then we get two answers, a positive or a negative answer. So x equals -7 plus the square root of 61 over 6, or we get x is equal to -7 minus the square root of 61 over 6. And so we can go ahead and type this in our calculator now. Okay, so we open up our calculator page. Okay, and if you have work from last time, just go to New Document. You don't want to save No, and then we're going to choose Calculator. Okay, we're going to type in our number. So -7. Now we're going to do a fraction bar first, since we have a fraction here. So we're going to do Control Divide, and if you're not sure, remember the symbols button is right next to the number 9, and then you can pick what symbol you want here. So we'd want to pick this fraction bar symbol. If you want out of that menu, just press Escape. Escape, right? So we're going to do -7 plus Control square root 61 divided by 6. Make sure it matches what we had. Enter, and there's our first answer. So nearest hundredth is is 2 zeros, so we want to round to the second decimal place. Okay, so that's going to be 0.13. The next number is the only one we look at. It's a 5, so we're going to round up. So this is going to be 0.14 or just 0.14. Okay, and then we want to do the same thing, but we want to change this sign to a minus. Now, on the Inspire, we can press the up arrow and highlight what we want, hit enter, and it'll bring us down so we can edit it. So now I can backspace, okay, delete this, and change it to a minus, okay? So once again, Control clear, we'll delete the line, we do up arrow to highlight the work we want, press enter, and then we can use that backspace, and then we can delete out and change. And that's an easy way to get our answer. So 2.646, but the next number is an 8, so we're going to round up, so it's -2.47. And there's our two answers to the nearest hundredth. Okay, so set notation would be 0.14, comma 2.47. And then we can also throw that or in there. X equals 0.14 or 2.47. And there we go, quadratic formula. The last thing we're going to do is talk about graphing. Okay. Remember, if you don't have the calculator, you can use the Desmos link, the desmos.com/scientific. And then this one, we're going to use the desmos.com/calculator. But I'll be viewing this on the TI Inspire today. So, home screen, because I want a new document. I'm not going to save. Open up a graphing page. Okay, if I want to add a new document to this, like I want to do a quick calculation, I can also press Control, and then right above Doc, it says plus page. I can add a page in here. And then I can toggle between them by either clicking at the tab up top or pressing Control and then the left right arrow will also move me to the different tabs up here. Okay, so we're going to type in our equation, which is -x squared, not minus, but -x squared, and then minus 6x. Double check, make sure that's right. Hit enter, and then we want to graph that. Remember, I can't see all the way up here, so I want to grab the axes. So move on your trackpad, move your guy over here, and then Control click. So Control click grabs the axis. You can see the hand has changed now, so it's grabbing. And then we're going to go ahead and move towards. Okay, the center is the origin 0, 0, and we'll zoom in on. We'll zoom out. We pull away, we zoom in. Okay. And then once we're here, now we want to find that maximum value. So menu, analyze graph, maximum, and then you're going to move over to the left, click, and drag to the right. By the way, it also works if you go the other direction, analyze graph, maximum. So if you start on the right and move over to the left, it doesn't matter. Give you that point. So it's a point -39. So remember, if we're using a table of values, okay, an XY table here, to graph, this point goes in the middle. So -39 is in the middle. That's also the vertex, -3, 9. We're going to pick numbers above and below that. -4, -5, -6, and then we're going to go to -2, -1, and 0. All right, so we want to view those points. So we're going to do Control T for tab, and then we can move our window up so we can see the symmetry. All right, so at -6, we're at 0, which means at 0, we're at 0. At -5, we're at 5, which means at -1, we're at 5. And then at -4, we're at 8, which means at -2, we're at 8. And I'm going to go graph those points. So -6, we're at 0. -5, we're at 5. -4, we're at 8. So that's 6, 7, 8. -3, we're at -9, or at 9. -2, we're at 8. -1, we're at 5. And at 0, we're at 0. Now, I might want to see where the graph is heading when it's going down this way. So what I could do is go up one more value. And so I can actually fit this point on here if I want. I can graph, even though I don't need to. 2, 3, 4, 5, 6, 7. I could graph the next point because it'll make I'll be able to figure out where this goes. If you don't worry about it, okay? You can always just graph, hit where that goes, and then add arrowheads. That'll be fine. But if we know that the graph is going to head down at -7, -7, then I know my graph can extend through that point, and it just gets a little more accurate. Now, if we needed to graph, let's say a linear equation, a line, and a parabola, I may want to add this point in, because if I have to find where those lines intersect, I'm gonna want my graph to extend all the way down, so to be super accurate. And I just need to work on drawing a straight line here. There we go. Okay, there's the parabola. There's our vertex. Remember, the roots or the zeros are where the graph crosses the x-axis. So these are the roots, the zeros, the solutions. Okay, so when it says state the roots of the parabola, we're just stating the x-coordinate only. So this is at x equals 1, 2, 3, 4, 5, 6, -6, or x equals 0. And we can see that on the table because that is where the y-coordinate is 0. Okay? And I want to go a little bit narrower. All right, and that's key. That's important here. So when the y-coordinate is 0, the x value there is our root, our solution. All right, and then the other thing we want to do is label our equation. So y equals -x², or I should say f of x because it's a function. You know, it's a function because it passes the vertical line test. So f of x equals -x² minus 6x. X and y are labeled. We're all good to go. Okay. Last question on the chart here. Alex, launch the ball into the air. The height of ball can be represented by the equation h equals -8t² plus 40t plus 5. H is the height in units. T is the time in seconds after the ball was launched. So I'm going to graph. Now this is giving me an interval. Okay. So when I see what it wants me to graph, this tells me that I'm not doing any arrowheads. Okay. And I'm ending with points. End with endpoints. So where these points are, okay, points. Where these points are, 0 and -5, wherever the y values are, I'm going to stop the graph at those points, okay, and I'm going to end it with the endpoints. It doesn't go any further. So I'm going to do a t-chart, and I'm only going to do my t-chart, okay, with points 0, 1, 2, 3, 4, and 5. Now I'm going to type this equation in. So once again, I'm going to get a new graph, new document. But if we want, we can always add one. So let's just add one here. So we can, I want to go back to the page I was at. So I'm going to go to current. I'm going to do Control plus and go to graph. And notice it says F2 because this graph had F1. It's just the second function. So I'm going to do -8. Now I can't do T because the graph is actually in X and Y. So instead of doing H and then T, I'm going to use X and then Y. Okay, So negative 8 x squared plus 40x plus 5 plus 40x plus 5. Go ahead and hit enter to graph. Once again, I can't see, so we're going to do control, and then we're going to click the button right in the middle to grab, and then we can go ahead and zoom in so we can see the vertex. Now we can super far, but all we want to be able to do is hit the vertex here. So menu, analyze graph, maximum, click and drag, and then you can see that that point, 2.5 and 55, is the vertex. So that point is actually going to be on our chart. This is important. We're going to graph 2.5 as well. So all these numbers, including 2.5. Okay, so let's do that first. And actually, what I should have done, really, is gotten the vertex and then filled in the table. Okay, so I would want to do 0, 1, 0, 1, 2, 2.5, 3, 4, and 5. Because I know the vertex is there. And I know that it's 55 at 2.5. Okay, Control T to see the other points. And then starting with 0 is 5. 1, you know what? I'm just checking real quick. Negative 18 squared plus 40t plus 5. Yep. Okay, just checking. I wanted to make sure that I typed that in correctly. Okay, so 1 is 37. 2 is 53. We know 2.5 is at 55, and then it's coming back down to 53. 4 is at 37, and 5 is at 5. Okay. So let's go ahead and graph this. Now we're going to graph from 0, right? And we're going to do all the way up to 55. So we can't just count by ones here, okay? So I'm going to have to count by something else. The easiest one to do would be to graph by 5s. So we could skip 5 and do 10, 15, 20, 30, 25, 30, 35, 40, 45, 50. We could also skip a line and graph every 10, right? So what I mean by that is this is actually going to be 5. That's 10. That's 15. That's 20. So it's actually counting by 2.5s. And the reason I might do this is because now I can actually fill up the whole graph here. Except I won't be able to do that, I think. 40, 50, no, I can. So 35, right, 40, skip 1, 45, nope, I can't because I need to get to 55 and I'll be off the graph. So we're going to have to do what we originally planned, which was to go by 5s. So here's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Don't really need to go any higher because I only go up to 55, and then we're going to graph. So now we're going in seconds. We're going between 0 and 5. I don't have to label the x-axis, but I can. Okay, so at 1, we are at, or I should say at 0, we're at 5. So I'm going to put a dot there. 1, we're at 37. That's just below 40. Okay, it's actually a little bit lower than, if this is 35 and 40, 37.5. It's actually a little bit closer to 35 than it is 40. And then 53, so it's the 2 is at 53, so it's a little bit closer to 55 than it is 50. 2.5, we know we're at 55, and then we're heading back down. So we're going to match the one right next to it. Oh, and actually, we would lose a point here. Can you see why? Hopefully you caught it. The vertex is at 2.5, 55. So this is actually, I went too far over when I did that. Okay, so here is my graph. Now I'm going to end right at those endpoints. I'm actually not going to go any further because it told me what values to use from 0 to 5. So I'm not allowed, I don't want to go any further than this. So first of all, how many seconds does it take for the ball to reach its maximum height? Remember, the maximum height is the vertex, which was the point 2.5 and then 55. So remember, the x stood for the time. So how many seconds? It takes 2.5 seconds. What was the maximum height of the ball? That's the y coordinate. That's 55 feet or 55 units. Okay, we'd want to check that. It just says in units. So we just say 55 is fine. Okay, and how long after he launches the ball does it take to hit the ground? Now, we actually can't see that, and it's not very nice, but we can check it on the graph, which is kind of neat. So I'm going to undo the table, Control to get rid of the table, and I'm going to zoom in. So Control click, okay, on the graph here, okay, and we're going to zoom in here a little bit closer. Okay, too close. Now you can see it's not a nice number where this goes, right? You can see where it's kind of hitting, but it's not a nice coordinate. So what I'm going to do is hit Menu, Analyze Graph again, and this time you can see the first option is 0. Remember, the 0 is what we're looking for. That's where the graph crosses the x-axis, the parabola. We're going to click it, and then same thing for the maximum. Click and drag, and it'll tell you exactly where it hits. So about how many seconds does it take? Well, it takes started. Remember, he kicked the ball at time 0, so it took about 5.12 seconds. So about 5.12 seconds. That's what it took. And all we had to do was do Menu, Analyze Graph, and then choose 0. And then expand our window. Now notice if you go to the left, it will give you the negative 0 here. And if you go to the right, it gives you the positive. So that's how you can kind of see both without having to click. Once you click on it and you want to get the other 0, then we do have to go Menu, Analyze Graph, and choose 0 again. And now we have to select that part of the graph to see that one. And then once you click twice, it makes that point nice and solid so you can read it better. Okay? And that is it for today, guys. I hope you have a great rest of your day, and I will see you tomorrow.